outside, and I can open it for you. And it can fit groceries, parcels, you know, in this configuration. But we can make other configurations too. We could deliver prescriptions, medicines. We could deliver smaller, more valuable items like iPhones. Anything that you would need and want delivered to your home or workplace, it could fit in here. Right now, it's ambient temperature, so it's not heat or cold controlled, but that's also something we could add going forward. It's also fully electric. So one of the challenges with last mile delivery is the addition of cars on the road. So you know, companies have started to crowdsource their delivery because they can't handle the volume of deliveries, especially around the holiday season. So instead of having more cars, you know, a car delivering one package from one store to one customer, we can have the robots be fully electric and using pedestrian infrastructure. So the idea is to reduce congestion, reduce carbon footprint of deliveries as well. Would you like to see a demo?
Sure.
So we're going to take our robot for a little bit of a walk. We'll just let it go around while I finish up the presentation. So there's a few ways that it can be navigated through the environment. Right now, the way we're going to control it is locally. So we'll have an operator with a controller walk the robot around. If we had come earlier, what we would have done is do the same operation you're going to see right now. Take the robot through the environment where we want it to operate, and we would build our own maps. So we don't rely on pre-existing maps. We basically can map any location, inside, outside, you know, multiple floors in a building. And we would use those maps to then tell the robot where it's allowed to drive. We would create routes and then send the robot from A to B. But the technology on the robot allows it to navigate that dynamic environment, encountering pedestrians, strollers, pets, you know, anything you could think of in the pedestrian environment. So let's send it on its way. And you can hear the sound that it's making. We worked with several disability groups to get their input on the best way for us to ensure we're you know, accessible and safe around all types of abilities. So one of their suggestions is making it have an audible sound so it doesn't ever sneak up on anyone.
Joan, the
Yes.
presentation's ready.
Okay,
Yeah.
thank you so much.
It's easy just to activate the left and right click.
All right, so we'll...
Oh, what happened?
It's a little off center, but we'll figure it out.
It might.
Okay, well, we covered some of this, but sort of stepping back a little bit, this is sort of half of our team. We have about 35 people. We're based in San Francisco. Our two founders are graduates of Carnegie Mellon University, and they focused on robotics. Our CEO was one of the first people to build a self-driving car, and he's worked on everything from submarines to moon landers. So we have a wide range of backgrounds in the team. And as I mentioned, you know, everything wants to be delivered. Everyone wants everything delivered right away when they want it. And here's some of the challenges of the last mile. One of the items I didn't speak about earlier was product experience. A lot of people we found are uncomfortable having someone come to their home and deliver something. And other people are uncomfortable with their food being in, you know, a personal car. So this is a, you know, secure environment. The cargo is locked. It's opened by the retailer or the restaurant, and then doesn't open again until the customer opens it with the code they receive on their cell phone or email. All right. And it's back. Okay. Let's see, we talked about the robots. And we do have a video. Let's see if we can make this happen.
Thanks, we're not connected.
Okay. Well, you got a live demonstration, so it's even better.
Is it on the internet? Is it?
I think it is, yeah. Okay, so a little bit about how it works for the delivery. You can see there's like a hub in the center of the city, so a truck would use the highway infrastructure, deliver to a hub. and then the robots would disperse from the hub to do the local last mile delivery. And here's some capabilities of the robot. So it can go up to 6 miles an hour. One of the measures we use when we're testing is politeness. So not only do we want to be safe, we want to be polite. We don't want to get in anyone's way. We don't want to block anyone on the sidewalk. So we're always conscious of how we're interacting with the people we're sharing the sidewalks and the crosswalks with. Okay. And thinking about the impact. So, a lot of people use delivery today, but not everybody can afford or has the availability to do an expensive, $20, $10 even delivery. So we want to make sure that we're reaching those that are homebound, the single parents who need a scheduled delivery and have a very specific delivery time, and then also find ways to address the food desert challenge. So this could be a device that would deliver fresh food where it's not immediately accessible in certain neighborhoods, and we think that this has a far-reaching impact not only to these groups, but everybody else asking for immediate on-demand delivery. So, thank you. Happy to answer questions if anybody has any.
Question.
Yes?
Does the robot operate elevators in the crowd?
So right now, we can take it into an elevator. Someday, on our roadmap, we do want to be able to use an RFID and have it be able to let an elevator know that it's waiting and could enter the car itself. Yeah.
Can you comment on some of your early customers and maybe their implementations, Joan?
Sure, yeah. So we did some work in one of, I think, the most complicated neighborhoods in San Francisco, the Mission District. So we had a partnership with Yelp E24, and we did deliveries from a lot of the Mission restaurants. They were very enthusiastic to be involved with us, and we delivered to homes and businesses in that area, and we learned a lot. We have since evaluated other industries, so we're looking at grocery, parcel, retail. We get a lot of inbound inquiries about how businesses and other industries want to use this technology. So we're right now crafting our next pilot opportunity. Yeah.
Thank you.
Would this robot be able to cater a lunch? But there's a lot of people on the sidewalk.
Mm-hmm. Yeah. So you mean in terms of the cargo size?
Yeah.
Yeah. So this configuration, it is the right size to fit a catering tray, just like you see back there. So it could fit several catering trays stacked on top of each other. And we actually did that for a restaurant in the Mission. Yeah.
What are the top couple challenges that this captor is facing?
I think one of the biggest ones is it's new. So there's no sort of groundwork laid out, especially for cities and states, for us to be able to operate. So we're doing a lot of outreach on our own, going to cities, going to towns, saying, here's what we are. We're not a motor vehicle, which would prohibit us from operating on the sidewalk. But we're also not a scooter or a bike. So help us figure out how to define what we are and to be able to operate in your city or town. Yeah. Mm-hmm.
Does it have on the roadmap, can it unload itself at some point?
Oh, yeah, good question. Yeah, I know there's robotic arm person here, so maybe we should talk.
Well, the reason I asked is that we've just deployed for LiftMaster Chamberlain their MyQ function that allows a UPS driver or FedEx driver to open your garage with a one-time key, drop the box off. It would be great because it would be easy to set this thing up to open the garage, come in, drop it off, and leave.
Yep, absolutely. We've thought about the sort of Dropbox application of it, having a little slide out of the robot to a secure location at the home as well, if it's an unattended delivery. Yeah, not in our immediate future, but possibility.
Joan,
Yeah.
quick question. I missed part of your presentation, but does that have to be manually operated by a person, or is it you can create a database and let it go?
Yeah, so I sort of talked through the local operation and the autonomy, but there's also teleoperation is what we're calling it. So once we send the robot out into the world, we can have somebody sitting back in the office, let's say San Francisco, and they can actually control the robot. So they can see 360 degrees around the robot, and they have all the controls to drive it. So yeah.
Thank you.
Yeah, you're welcome.
For the battery life, how many deliveries do you think this machine is capable of doing with the 8 hours?
Yeah, it depends on the distance between the deliveries. So the battery life is about 5 to 6 hours. It depends on the terrain, how many hills we're climbing, how much waiting time we have at crosswalks. But we intend to have more than one delivery an hour. Yeah.
Have you heard of TV bots?
Yes.
They're up in Berkeley.
Yeah.
How is it different in terms of technology? Because but those bots are extremely small and they are limited. So how is it?
Yeah, I think size is one of the biggest differentiators. We want to be a little bit more flexible in what we can carry and think outside of food delivery. But I don't know their roadmap particularly. But yeah, it's a similar. Yeah. There's actually a lot of people thinking about this field. You probably saw FedEx announce they have a last mile delivery robot. Amazon is thinking about it. So there's a lot of players. Yeah.
Have you had any problems with vandalism or theft?
So, yeah, right now we still have an ambassador with the robot at all times. So we have a person with it to basically be a chaperone, to be there in case we have questions about what it is, what it's doing. We want to be educators to everyone about it and not sort of just show up on somebody's sidewalk. And so we haven't had issues with vandalism, but it is something that we are aware of. So one of the things we can do is we can see everything that's going on around the robot. And then we can control it. We can also listen and hear what's going on. And we also have on our roadmap to add an ability to talk through the robot, so we can let people know, hey, we see you, please stop that. We're going to call the police. Yeah.
Once the robots go independent, do you guys have an idea of how quickly they can recover from unexpected road work that closes down sidewalks?
Oh yeah. So if the robot is stopped by unknown obstruction, it'll actually call back to home and let us know. So we'll get a little alert on the screen when we're telehopping, and it'll say like, "Hey, I need some help. Can you see what's going on around me?" Mm-hmm.
So during a delivery, is it capable of the robot dying while delivering? So like for example, if it's going up the hill in San Francisco, it takes a lot of energy. So how would that make an impact on going up the hill in San Francisco on a low battery?
Yeah, so we monitor the battery life through the teleop center, so we know if it needs to come back home and charge it. Yeah.
So during the delivery, if it dies, you take it back, or would you complete the delivery first?
Oh, I mean, yeah. If we know that it's a low battery, we would complete that delivery and then come home and charge it, or we wouldn't send out that robot if it was a low battery. Yeah. I think there's one back here.
What do you anticipate is the sort of backup support that you need to monitor and operate these?
Yeah, so right now we're basically one-to-one. So we have an operator back at home monitoring the robot in the field, but we want to improve that metric to obviously scale to meet the volume of deliveries we'd like to hit. Yeah.
Do you have an idea of how long how you progress on that?
It's not very long. We've been pushing those boundaries and having more robots per operator and working on that right now. Yeah, we still have a relatively small fleet, so we're not talking hundreds of robots to one person yet. Less than 10. Yeah.
How does it know that the light's changing?
Oh, great question. So as part of the mapping, it gets to the end of a sidewalk and it waits. So at this point, it'll let us know back at home that it's at a crosswalk, and then we'll tune in, we'll watch for the light signal change, and then tell it to cross. So there's human intervention in every crosswalk right now.
So for last mile delivery, how would you compare and contrast with the drones?
Oh, yep. So I think drones require more infrastructure, sort of aerial infrastructure. There's a lot of regulations around privacy and where drones can and can't fly, especially in really populated areas. So I think there'll have to be some development and work in that area to really see drones working in downtown areas and like even residential suburban areas. I think there's great applications like Zipline's doing great work in Africa, doing long distance rural deliveries. But yeah, I'd like to see how drones move forward in more populated areas. Yes.
Are there any weather restrictions, or are you capable of just switching through all?
Yeah, so we're based in San Francisco, so we tackled San Francisco weather. One thing we have not tackled yet is snow. So we can operate in, you know, good weather, rainy weather, but not snow or ice.
What about floods?
Floods? Yeah, it's amphibious. It can go through puddles, but yeah, it's standing water. It's not ideal. All right, you feel free to. I don't want to monopolize the conversation. I'll stay around for questions at the end too.
That would be great.
One more?
Sure, yeah.
Just curious, the batteries are going to be swappable, or are they only rechargeable built in?
Right now they're rechargeable. Yeah, so we'll plug them in and charge them that way. We're evaluating swappable versus wireless charging. Okay.
Thank you, Joan.
Oh, you're welcome.